Go live with this one. All right. So, and then 3.2. So that's 3.2. So that we must state the properties of electrons, protons, and neutrons. All right. Does anybody know the properties? What we mean by properties of electrons? All right. Anybody? We have O'Neill, Ruda, Abigail, and Chrysanthi. What do we mean by properties of electrons? Or let's put it another way. What are three things that you know about electrons? Three behaviors that an electron has. Yeah.
So electrons is equal to the number of protons.
All right. Let's stick up in there. That is true. But let's go further here. This part says here properties related to the mass and charge. Mass and charge only. So in
Sir,
other words, yes, go
they
ahead.
have negative charge, sir.
They have
Electrons
what?
have negative charge.
They have negative charge. Uh who is that? Chrysanthi?
Abigail, sir.
Abigail. Yeah, well done, Abigail. Definitely true. Electrons have negative charge. Let's write that down. Yeah. Electrons have negative charge. That is very important. All right. What else do we know about the electron now? It is what about the all right, let's talk about the proton because them say properties of protons too. What type of charge does the proton have?
Positive.
Oh, Christianity. That's loud. Very good. Yeah. Protons have positive charge. So once you know this, then you're pretty much you're halfway there. Protons have positive charge, and we use a plus sign for that. All right, so that's important. And what about the mass now? Because the mass. Oh, by the way, even before we go to the mass, what about the neutron though? What charge does a neutron have?
It has no charge.
Well done. Well done. Well done. Neutrons have no charge. All right, so that's very good foundation there. No charge whatsoever. Zero charge. All right. All right. So then that's the three. That's what they mean by properties, right? Here. Talk about the charge of the electrons, and then next we talk about the mass of these particles here. All right. Do we know anything about the mass of the electron, the proton, and the neutron? Do we know which one is the largest, which one is the smallest?
Sir, the Sure. mass of proton is 1.
Okay, good. One what? They say one something. It's a very good point. One something. If you could tell me $1, you know,
AMU.
AMU. All right, that's good. Yeah, let's write that over here. Mass of proton. Did you do that in class?
Yes, sir.
Very good. Okay, is 1 AMU. All right. Does anybody know what AMU stand for?
Atomic mass unit, sir.
Very good. Well done. Atomic mass unit. So hope everybody is on the same page with this. All right. The mass of a proton is 1 AMU. Also the neutron has the same mass as well. So proton and neutron have the same mass. All right. So AMU stands for atomic mass unit. Very important. AMU means atomic mass unit. All right, and right now we're just writing this on the syllabus here because we need to. So because when this syllabus is actually is online, guys, so you can go in Google and you type in CXE chemistry syllabus and you'll get a little booklet with this all the objectives. But a lot of students don't know how to read the syllabus. So what I'm doing with you today is just showing you how to read the syllabus and understand. All right. So them just divide all of the topics into sections and all the little things that you're supposed to know, which will be similar to the questions they will ask in the exam. So the AMU is important to know because it describes the mass of each particle in an atom. It's the atomic mass unit, and of course the proton and neutron have the same mass. But what about the electron now? Does the electron have the same mass as the proton?
No, sir.
No. Okay. So all right. So what the mass of that would be now? Uh did I give you a mass for that? For the electron?
Yes, sir.
All right, what number you have for the mass of electron?
1/1837.
Yeah, that's definitely true. All right, so electrons have a mass. All right, so electrons have a mass okay, 1/1837 AMU. So that's just a fraction of that of a proton. So all right, that's important stuff to learn. These are, as I say, guys, you'll see these in exam questions or in tests uh pretty soon or later on though. All right, so that is covered. 3.3 now is asking us to define atomic number. We underline the word atomic number and mass number. Can you do this, students?
Yes, sir.
Very good. Okay. One person saying yes. Just hold on. Let's mm, and let's send this through. All right. So if you say yes, what is a mass number? What's the definition for mass number?
Sir, how heavy the atom is, sir?
No, can't accept that. Need something more detail on that. Atomic mass, sorry, atomic number and mass number. They are two different words. So define the mass number and define proton number. Start with anyone.
Sir,
Sir,
atomic.
Yeah. Okay, hold on. I heard two persons talking. Sounds like between Abigail and uh Chrisanti. All right.
Sir, atomic number, sir, is the amount of protons in the nucleus of an atom, sir.
Okay.
Think.
All right. So proton number is the same thing as atomic number. That's the first definition. All right. And that would have been Abigail. All right, Chrisanti, you were saying something else?
No, sir. The same thing with Jago says, sir.
All right, cool. All right. So proton number is the same thing as atomic number. All right. What is the mass number now?
Sir, mass number is the total number of protons and neutrons in an atom.
Okay. So that's Christianity saying. Total number of proton and neutrons. So yeah, mass number is defined as the proton number, yeah, plus neutron. When this neutron spell wrong here, so yeah. All right, so that is it, That is it. Mass number is equal to the proton number plus the neutron number. So if we could just probably switch around some of these things here. The atomic number is the same thing as the proton number. The mass number is the proton number plus the number of neutrons. Everybody get that?
Yes,
Yes,
sir.
sir.
Yes, sir.
And please record that information, write it down somewhere and learn it, and don't forget it. Very important. These things come on exam regularly. All right. So, all right. 3.4 says to define the relative atomic mass. All right. I won't go into this yet because it going to, well, cause us to go into some technical details here. But relative, all right. It's according to this though, the relative refers to carbon 12. So when we speak of that later on, but not now. 3.5 though is however more important for us to know right now, because they say interpret notations of the form X, A, B, C, D, where A is the mass number, B is the atomic number, which you should know. The charge now, this is something that we will have to spend time to learn, and the number of items in the entity there, as X is a symbol of the atom. All right. This is something that, again, let's put some asterisks here, because as you get more knowledgeable, you will know how to do this. But certainly they really wanted to know, look at the periodic table and then be able to see what the numbers around elements mean. No. All right, I will do that another time. And certainly we're just doing a little review today. This is very important now. We're at 3.6. All right. And the next few minutes we have in class now, we need to try and learn this, because this they're asking exam quite often. All right. And here it is. All right. Can anybody pronounce this word that I'm underlining in red there?
Isotopy, sir.
Okay. Isotopy. Yeah. All right. And have you seen this term before?
No, sir.
No, sir.
Well, you guys better learn this word today. Isotopy is the tendency of elements to exist with different number of neutrons. So atoms of element having different number of neutrons. So that is, and that's giving you some example here. All right, let's just go into isotopes. All right, so we have isotopes here. Basically, best way for you to explain that now, guys, is this. You're coming like you ever plant something, or say like certain fruits growing on tree, like say oranges or mango, and the question is, even though it is one orange tree, do all of the oranges look the same?
No, sir.
No, sir.
No, no. All right, so it's the same thing now with the atom. Now, when we are talking about a specific atom, let us say hydrogen, or let's say we are talking about the element hydrogen, then, which is hydrogen with many atoms. So that's so when you call an element by name, understand that that a single element is many atoms combined together. All right, so it's just that in chemistry we only focus on one of those atoms. All right, so you find out, say, if you get hydrogen gas, for example, so it's a gas that they use to do quite a few things. All right, let's say you have some hydrogen gas. Then it means that you have millions of or billions of atoms there in one place. All right. Now those atoms, millions of atoms, are not all completely the same. All right. So it's coming like, say, for example, if you were to pick all the oranges of the tree, right? Not all of those oranges you probably would want to sell or eat them. All right. Some of them might not look so nice. All right. And so those would be like isotopes. They are the same tree, but them look different from the rest. Right? So in the same way, now isotopes is defined here as atoms with the same number of protons, which it means that it's the same element, but different number of neutrons. So some of these atoms will have little bit different number of neutrons due to whatever happened with the element there. So that's the case here, guys. It'll come in like you have a sickle cell or something, you know, you cells them, or something just different with one of them, or maybe a person is born with maybe all the normal features, but maybe let's say they have an extra finger. Then you know that's like that'll come in like an isotope there. Same but different. So same everything, but one thing is different. And that's what isotope is in chemistry, guys. So let me just close by saying this now. I'm going to show you something here. All right, let me show you this example here, and I want you to tell me which element is being shown here. All right, which element is shown here?
Lithium, sir.
All right, so O'Neill is saying lithium. So all right, so good to know you're still there, O'Neill. So the lithium. All right, so we know. And what gives you the clue that it's lithium?
The symbol, sir.
Oh, the symbol of the element, which is one of the objectives that you should accomplish here. All right, so lithium element has a symbol Li. All right, and certainly that's a symbol. All right, so now let's go deeper now. What? All right, so there are three different lithium here, as you can see. Right. What is common to all three of them?
The atomic number, sir.
All right, stick up in there. All right, I'm hearing two answers. So, who said atomic number? Was it Abby?
Chrisanti, sir.
Chrisanti? Yes. All right, Chrisanti, you're saying atomic number is the same. Hold on to that, O'Neill. What are you saying?
That was what I was going to say, sir.
Okay, so we are agreeing then. All right, and I hope Rhoda and Abigail seeing this as well. Chrisanti is saying that the atomic number is the same. So let's use probably a different color to illustrate that. Different. So this is the same. All of these here, same. All of this is the atomic number. And what we said was the definition for the atomic number.
The number of protons in a.
Yes. So we're gonna say proton number actually is the same as the proton number. So let's write that proton number is indeed the same. All right. So this is it now, guys. So we have lithium, the symbol, Li, and then the 3 represents the proton number. So then question is now, what do these top number mean? Why are the top numbers different?
Sure, they have different mass, sir.
Okay, good. It's actually not writing so good. But all right. Is it a different mass, you say? All right, so we agreed on that this is the mass number. Definitely the mass number there. And that's correct. So what you are just indirectly saying is that, well, they have the same proton number but different mass number. That's the definition for isotopes. So let's change this. So that's not writing so wonderful here. We change this to black. All right, so isotopes are atoms of the same element. All right, having the same proton number but different mass number, or different, well, I said about different mass number, really. Let's just start with what you learn from this then. Different mass number. All right. So typically, guys, in a question for in an exam situation, they could ask you then, all right, determine the number of neutrons in each isotope, which you should be able to do. And things like that. But I think at 10:38 no. But at this point now, guys, I just want you to leave here knowing the definition for isotopes, so that we have something we can build on for next class. So next class now, I want you to look on the uses of isotopes. All right, let's look at the importance of isotopes. All right, and let's
Sir,
yes, go ahead.
sir, so it's every atom and isotope, sir.
No, all right.
Like from 1 to 20, sir. There are atoms from 1 to 20, sir.
Understand, say isotope is a behavior of an element, right, O'Neill? So, well, you could argue then. So you're asking now if each of those atoms have isotopes. That's what you mean to ask.
Yes, sir.
Yes. Well, each of them do have isotopes. Hydrogen, for example, has 3. Hydrogen, the first element. Helium does have a couple as well. So you could say all of them from 1 to 20 may have isotopes. We'll have to confirm that though, because I'm not sure what the modern research is saying though. But certainly hydrogen does have 3 isotopes, and helium has a couple as well. Lithium, as you can see there, having 3. Beryllium has a couple as well. Boron does have so yeah, all them have. All right. So yeah, it's like when God create them, he just make some of them atom kind of gifted. Might have one more than the normal, and then because of that, it just behave differently. All right, so that is what I wanted to research now for next class, which is the importance of isotopes, really. All right, of importance of isotopes. Sorry, yeah, to humans, because there's a lot of uses for isotopes. All right, so and the other thing to note is that all right, so we know that. Anybody remember the 2 elements we said are found in water? Anybody? Nobody knows the 2 elements used to make water. All right. Anyway, let's continue then. So this is, we have medicine, archaeology, and of course industry. All right. So these are the, again, we're saying that the three uses of isotopes. Look for them in these. All right. No, that's your homework. And that would be for me. All right. So going through what we have done so far, guys. Important thing is to know the definition of the isotopes. These what you're seeing here are actually examples of isotopes. Um, so the point is that some. All right. So many elements, not some, but many of them have isotopes. So many elements have atoms that are isotopes of each other. Have no. All right, let me show you this now. Anybody know how many teeth they're supposed to have? By the time they reach 18.
32, sir.
32. Okay. So do you think everybody will have 32 teeth by the time they reach 18?
No, sir.
No. Right. And why is that? Because
Sir, some people teeth can rotten and then take it out, sir.
some can be removed and so on, eh? All right. Yeah, and again, you could argue that it's the same thing though. But you know that persons have even maybe 36 teeth. Person may have more teeth than the 32. So those persons can have less as well. Think there's a record for the person with the most number of teeth in the mouth. You can probably research that, you know. But it's the same thing there with these elements here. You have some strange behavior of elements here. Many elements have atoms that have isotopes. So example would be hydrogen. No. And I ask the question, which two elements make up water? And nobody in the class
The
knows.
hydrogen and oxygen, sir.
Yeah, I would have expected everybody to know that. But well, that's actually the answer. But if you say hydrogen and oxygen, the question now, you as a student with the chemistry now, you learn about isotopes now. The question is which one of the hydrogen? Because hydrogen has 3 isotopes. So are all of the isotopes the same? You know, that's the question. That's like we say when you pick orange, you pick an orange off a tree. You say, well, not all of the oranges gonna be the same. All right. So maybe a taste one. Well, it's the thing about it. All right, even everybody in this class love mango.
Yes, sir.
Ruda, yes, that's what I used to get it to talk now. So you love mango, Ruda. All right, what you like most about mango?
Sir, me did that talk long time, but I just never did pay attention here, so, sir.
No man did. I mean, all right, Ruda. All right, I feel attention now. But what you like most about mango?
Sir, the taste, sir. Not sir, everybody,
Yes,
the taste.
the taste. Lovely. You get any mango since this mango season here start?
Sir, enough, sir.
Whoa, you're fortunate, so man. You get mango in April. All right, the mango season not even setting good yet. All right, that's good. You're fortunate. You have a mango tree at home?
No, sir.
Okay. Well, you're blessing. You're blessed. Point is that, guys, we want to know by next class which hydrogen is used to make water. All right, that is an important question.
Sir,
Yes, go ahead, O'Neill.
sir, the one with the mass number 1, sir.
Oh, okay. Hold on to that for next class because I don't want to go too much into your break time. So But good thought though. So, guys, all right, that's it for today. Remember that we focus on learning about isotopes today, and this is your homework, and that's for Wednesday's class. All right, this is based on a past question on CXC that has come before in CXC. So, try and answer this question and come prepared to present it. All right. So, guys, thanks for coming out this morning, and enjoy your rest of your weekend.
You're not
All right.
writing in the register.
Register. Whoa. Who remember the register? Oh, that's lovely. So register was on the other one now. Let me go back to the other slide. Yeah, actually I started out with this slide and I never continue here. Let me see who there now. Alright. I know I keep register here. So I'm seeing it's gonna be we have O'Neill and we have Crisanti. And we also have we have Rudan and we have Abigail. All right, so all right. Oh, by the way, before you guys leave, did how you like the StreamYard here? Is it you like it better than Zoom?
Yes, sir. Sir, cause we have to wait to get left in the classroom, sir. Sometimes we did that for too long.
Oh, gosh. All right. You're saying something, O'Neill?
So StreamYard now, sir.
I understand. Yeah, we'll try sort out that. But then good thing is that we can use StreamYard and Zoom together. So anyone you prefer, use that. You know. All right, but all right, guys. As we say, it's good to have you here today. And just as we say, guys, just do no homework and stay on top of things here. All right, so let me save this. Today is the 30th. Yeah, let's see back up here. Today is the 30th. So let's change the date there. That means tomorrow is the 1st of May. Let's save this one. All right. Let's save that now. All right, so meanwhile, let's save, guys. All right, guys. So try to see if I get the chance I could send the notes in the group here. It's going to be kind of difficult to do still, but I'll try. All right, guys. But the video is actually on YouTube anyway. So it's on the channel. All right, guys. So see you guys next week. All right.